Hi guys. A particular cubic polynomial g of x with rational coefficients has a 0 of 1 minus 3i and a remainder of 162 when divided by x minus 4. If one of the zeros is a positive integer, find the largest possible value of the leading coefficient. Largest possible positive value of the leading coefficient. So first off, we know it has a 0 of 1 minus 3i, so there's a 0 of 1 plus 3i as well. And then the last one's a positive integer. So we know that it's going to be, how do we do this? It's going to be, oh, I feel like we use a quadratic equation. It's going to be 2 over, or no, I don't know. It's going to be x minus 1 minus 3i times x minus 1 plus 3i. So it's going to be x squared minus x minus 3ix minus x plus 1 minus 3i minus 3ix. This is going to be plus 3ix minus 3ix plus 3i and then minus 3i squared, so it's going to be plus, so it's minus 9i squared, so it's going to be plus 9. These two cancel out, these two cancel out, so we have x squared minus 2x plus 10. Let me just think in the determinant, it's going to be b squared, which is 4 minus 4 times a times c, so minus 40. Wait, what, 4 minus 40? So negative 36, so yes, so yeah, okay, this is correct. So it's going to be this. So our entire thing is going to be this minus 2x plus 10 times a times x minus p. Okay. Well, I just realized why this works. A works because if in the determinant there's b squared, which a will show up twice, and it'll be a squared b squared. And then for ac, so a will show up a squared times a cubed times c, so take out the ac, it's a squared, and then you factor out a squared, you get a. So I understand it now. Okay, so we have followed this. Let me make this like 50% and make this yellow. We have done this. We have done this. This little thing. We have done this little thing. It's a cubic polynomial. We just need to find the, we just need to do this part where it's the remainder of 162 when we divide it by x minus 4. Okay, so we need to divide this by x minus 4. The issue is we have two possible values, but we just need to maximize one of them, so it doesn't even matter. Okay, so let's try this. Let me, do we need to expand this? So we get a times a times x cubed minus 2x squared plus 10x minus px squared minus 2xp plus 10p. So we have a times x cubed minus 2 plus p x squared. Sorry, I have like no room on my desk. Minus 2 plus p x squared plus 10 minus 2p x plus 10p. Okay. Now just putting a in here, we get a x cubed minus a times 2 plus p x squared plus, it's gonna be, we could factor out the 2 here, so we have 2a times 5 minus p plus 10 AP. Okay. Now we need to divide this by x minus 4. So we have x minus 4 dividing ax cubed minus a times 2 plus p x squared plus 2a times 5, minus or plus, minus p x plus 10 AP. We're dividing this by x minus 4. So our first thing is we want to subtract. It's going to be ax squared. So ax cubed minus 4ax squared. So this gives us, these two cancel out, and then we add this. So it's going to be 2 it's going to be a times, factor out the a, and then it's going to be 6 plus p x squared. 6 plus p x squared. Then bring this one down. We get 2a times 5 minus p x. This is oh shoot, this is, so it'd be, if we put this in, it'd be minus 2a x squared plus minus ap, and then we are adding plus 4a. Okay, so this is just going to be positive 2a, and that's going to be minus p. So what we want to do this time is multiply it by a2 minus px. So that would give us a2 minus px squared. So these two cancel out, and we subtract this. Then we do minus 4 times a times 2 minus px. So these two cancel out, and then we just move this here, then it's going to be plus this. So it's going to be, let's write this out. So 2a, I'm going to get rid of the a for now because it's not needed. 5 minus px plus 4 2 minus px, right? Yep. So we have 10x minus px, no, minus 2px plus 8x minus 4px. So this gives us 18 minus 6px. 18x, and then of course this all has a in front of it. So then we get 18 a times 18 minus 6p times x plus 10 ap. So what we want to do now is oh my god, this is going to be so annoying to actually solve, but it's fine. So we need to multiply by a times 18 minus 6p. You could factor out the 6, I see. So this cancels out, and then our final thing here is going to be 10 AP. Oh no, this isn't that bad. This isn't that bad. 10 AP. Then we want to subtract a times 18 minus 6p times 4. Okay. Let me rewrite this. I'm going to bring this over here so I remember it. Okay, so rewriting this, we get 2a times 5p. No, we can take out, okay, yeah, 5p minus 4 times 18 is 472. Then we do plus 24p. So 2a and then this is the remainder. So this is all equal to 162. A has to be a integer, positive integer, and p also has to be a positive integer. So realistically, actually, I could divide this by 2, and we get 162 divided by 2 is 5081. So it's going to be a times 5p, no, 29p minus 72. 29 is in fact a prime number, so interesting. The largest possible value of a should be 81, if this is possible to be 1. Let's see. 29 times 2 is 58. 29 times 3, 29, 58. 29 times 3 is 60 plus 27 is 87. Is that true? Yeah, that's true. So the smallest possible thing that this thing can be is 87 minus 72, which is 15. Oh, shoot. That's bad, because 18 doesn't factor this. Excuse me. This times 4 is going to be 80 plus 36 is 116. 116 minus 72 is going to be 3, 4, so 40, 4, I think? So this isn't getting anywhere, because the largest possible positive value has a rational coefficient. So p doesn't have to be an integer. Oh, it is, if one of the zeros is a positive integer. Let me make sure I did this right. We do minus x times a times 18 minus 6p minus 4. I think I made a mistake. It's going to be plus here. Okay. So that makes this a plus and this a minus. So that reconfigures the whole thing. That makes this negative 19p plus 72. Okay. Or 72 minus 19p. So, interesting thing here, these two both still don't share a factor, which means we can't factor anything out. But, okay, let's try. So when p is 1, we get 72 minus 19, which is going to be 13. Not anything. What the heck? That's not what that is. 72 minus 19 is going to be 62 minus 9 is going to be 54, or 53. This times 2 is going to give us 38. 72 minus 38 is 42 minus 8, which is uh 30, 42 minus 8, which is 34. This times 3, p times 3 is, or 3p, oh my gosh, when p is 3, this is going to be 30, 52, no, 57. 72 minus 57 is 22 minus 7, which is 15. I don't know why oh my gosh. So the thing is, none of these are, oh, I see another mistake. Oh my gosh, thank goodness. I thought I was totally gone. So we turn this into 2 times 5. We need to turn this into 2 times 2. Factor out the 2's. So this is just 2 times this. So this is 36 minus 12. Oh my gosh, okay. So this is gonna be, again, I believe a prime number. 5 minus 12 is gonna be minus 7, so 36 minus 7. So when this is 1, we get 29. 29, then we get 22, then we get 15, then we get 8, then we get 1. So this can in fact be 1. This goes to 1 because p equals 5. Then a goes to a is equal to 81. So our answer is 81. Oh my gosh, let me check. Okay, so I totally got that wrong. I think, okay, so I didn't get this right. But I think I must have made a mistake in this process here, because that's not what they got. I mean, of course I got this correct, because this was like the easiest part. But then what they said from here is they used a theorem called the remainder theorem, and they said, let's say this is equal to g of x. They said that g of x is equal to, or g of 4 is equal to 162, which is a very interesting, it's a very interesting theorem I've never heard of. So putting this in here, this turns to 16 minus 8 plus 10, which is 18. So we get 18a times 4 minus p is equal to 162. 162 is in fact divisible by 18. It's going to be 18, which is 2 times 9. So divide by 2, we get 81. Divide by 9, we get 9. So a times 4 minus p is 9. 9? 4 minus p. So this is maximized when a is equal to 9. 9? P is equal to 1. Or p is equal to 3 to make this 1. Cool. So I didn't get it right, but I understand totally how I did it. Or how it works, because I just didn't know the theorem, I think. But what I'm thinking is if I did the way I did, I should have still gotten the correct answer. I probably just, like, did some kind of, oh, I get an 18 here. That's interesting. I must have done the math somehow, the algebra. Cool, thank you guys for watching. I'll see you guys tomorrow. Goodbye.